6.3 Finding unknown coefficients. Learning intention. To use graphs to determine the equations of linear and quadratic functions. Success criteria. I can find the gradient and intercept from a straight line graph. I can write the equation of a line in the form y equals ax plus b, or y equals mx plus c, as we will be used to in our formula book. I can use points on a graph to find unknown constants. I can determine the equation of a quadratic from its graph. I can find x-intercepts, y-intercepts, and turning points from a quadratic graph. I can use given function values to form and solve equations for unknown constants. Finding unknown coefficients. The function f of x equals 2x plus 4 represents a straight line. So here's our straight line highlighted in yellow, so 2x plus 4. And we can see that this line crosses the y-axis at 4. So that is our y-intercept, the plus 4 at the end. And the 2 is our slope. So if we were to draw in a triangle, we would see that the rise is 2 and the run is 1. So 2 over 1 is 2, so a slope of 2. The function f of x equals x squared plus 2x minus 4 represents a shape like that shown on the right. This smooth curve is called a parabola. So it's a U-shaped graph. So when we have positive x squared, we have a U-shaped graph. If we have negative x squared, we have an N-shaped graph. Consider the function f of x equals ax plus b. If we are told that 2, 4 is on this line, this is another way of saying that f of 2 is equal to 4. So if we input 2, we output 4. So our x value is 2, our y value is 4. Similarly, if 3, 0 is on the line, then f of 3 is equal to 0. So if we input 3, our output is 0. Our x value is 3, our y value is 0. The following example illustrates how to find unknown coefficients of a function when given some couples of the function. Example 1. The given diagram shows part of the graph of a function. Y equals ax plus b. Find the values of a and b. So we don't know what the equation of our line is, but we do know 2 points on the line. So 3, minus 2 is on the line y equals ax plus b. If y is equal to ax plus b, we can label our point xy. So we can replace the y with minus 2, replace the x with a set of brackets, and into the brackets we put our x value, which is 3. So we have minus 2 equals a times 3 plus b, and a times 3, a number times a letter, we stick them together. So get minus 2 equals 3a plus b, which is the same thing as 3a plus b is equal to minus 2. So it's better to have the letter terms on the left and the constants or the numbers on the right. We were also told, or we can see from our diagram, that minus 1, 2 is on the line as well. So in the same way, we're going to write out our equation y equals ax plus b. We label our point xy, replace the y with 2, replace the x with brackets, and into the brackets put minus 1. And then a times minus 1, a number times a letter, we stick them together. So we get 2 times minus 1a, or just minus a, plus b. So we have minus a plus b is equal to 2. So now we have 2 equations in terms of a and b, and we're trying to find the values of a and b, so we're going to solve them simultaneously. So we have 3a plus b is equal to minus 2, and then minus a plus b is equal to 2. We're going to solve them simultaneously. So we're going to multiply the second line by minus 1. So the top line, 3a plus b is equal to minus 2, just stays the same. And then minus a times minus 1 is a, and b times minus 1 is minus b, and 2 times minus 1 is minus 2. Now our b's will cancel, and we have 3a plus 1a, which is 4a, and minus 2 is minus 4. And solving for a, we divide both sides by 4, so a is equal to minus 1. So we were asked to find the values of a and b. We found a, we now need to find b. So we write out one of the equations, it doesn't matter which one. We swap the a for brackets, and into the brackets we put minus 1. 3 times minus 1 is minus 3, plus b is equal to minus 2. So we're trying to find the values of a and b, so we need to solve for b, get b on its own. So the minus 3 comes over the equal sign, becomes plus 3, so b is equal to minus 2 plus 3, so b is equal to 1. So we were asked to find the values of a and b. The values of a and b are minus 1 and 1. Now, we weren't asked to actually come up with a function, but sometimes you are. So if we go back to what we were given, y is equal to ax plus b. We swap the a for minus 1, we swap the b for 1. So the actual function of this line is y is equal to minus 1x, or just minus x plus 1. Quadratic functions. A function such as f of x equals x squared minus 3x minus 4, which contains a term in x squared, is called a quadratic function. So this U-shaped graph here in red, this is the function x squared minus 3x minus 4. We can see that it crosses the y-axis at minus 4. So the constant at the end there is minus 4, so it crosses the y-axis at minus 4. We can also see that the roots of this function are minus 1 and 4. So the places where it crosses the x-axis are minus 1 and 4. This function belongs to a family of functions in the form f of x equals ax squared plus bx plus c. So where we have an x squared term, an x term, and then a constant. If we know points that the curve passes through, it is possible to calculate the value of some of the coefficients a, b, or c. The diagram shows a curve crossing the x-axis at the points where x is equal to minus 1 and x is equal to 4. So highlighted there in yellow, the roots of the equation. These numbers are the roots of the equation. So if x is equal to minus 1, then x plus 1 must be a factor. So we just put it into brackets and change the sign. And likewise, if x is equal to positive 4, then x minus 4 is the second factor. So therefore, the equation of the curve is f of x equals x plus 1 multiplied by x minus 4. So we multiply the two factors, which gives us x squared minus 3x minus 4. So here's our rough work. X plus 1 times x minus 4 is x times x minus 4 plus 1 times x minus 4, which is x squared minus 4x plus 1x minus 4, which is x squared minus 3x minus 4. So we can see we do get x squared minus 3x minus 4, which is what we started with at the very start. Example 2. The graph of the quadratic function f of x equals x squared plus bx plus c is shown. Find the values of b and c. Hence, which means we're using what you've worked out, so using our values of b and c, write down the coordinates of p and q. So point P and point Q. So point P is one of the roots, so it's one of the points where the curve crosses the x-axis. We can see we've one labeled already, minus 1, 0, and Q is going to be the y-intercept, where the curve crosses the y-axis. So we know 2 points on our curve. We've got 4, 5 and minus 1, 0. So it's quadratic, so it's U-shaped, so positive x squared. If it was negative x squared, it would be n-shaped. Minus 1, 0 is on the curve f of x equals x squared plus bx plus c. We're going to label our point x, y. So there's our point minus 1, 0, and the x value is minus 1 and the y value is 0. Therefore, f of minus 1 is equal to 0. So if we input minus 1, our output is 0. So f of minus 1 is equal to 0. So f of minus 1, so we're going to write out the function that's been given, which is x squared plus bx plus c. So we're going to swap each of the x's for brackets. So we've got brackets squared plus b times brackets plus c. And into those brackets, we're going to put minus 1. So that's coming from here in the question. So we've got minus 1 squared plus b times minus 1 plus c. And that's all equal to 0 because our point is minus 1, 0. So when we input minus 1, our output is 0. So when we input minus 1 in place of the x, our output is 0. So minus 1 squared is 1, b times minus 1 is minus b, plus c is equal to 0. So we're going to bring the 1 over the equal sign. So we've got minus b plus c is equal to minus 1. So we're trying to find the values of b and c. So we're going to do this again with the other point, so 4, 5, and to create another equation in terms of b and c that we can then solve simultaneously. So 4, 5 is on the curve f of x equals x squared plus bx plus c. Again, we label our point x, y. Therefore, f of 4 is equal to 5. So if we input 4, the output is 5. So f of 4 is equal to 5. So we write out our equation. So x squared plus bx plus c, swapping each of the x's for brackets. So that's coming from the question there. And we're going to input 4 inside the brackets. And that's all going to be equal to 5. So 4, 5, f of 4 is equal to 5. So 4 squared plus b times 4 plus c is equal to 5. So 4 squared is 16, b times 4 is 4b, plus c is equal to 5. And bringing the 16 over the equal sign, we get minus 16. So we get 4b plus c is equal to minus 11. So now we have a second equation in terms of b and c, and we're going to solve the two of them simultaneously because we're trying to find the values of b and c. So again, we have minus b plus c is equal to minus 1, and b plus c is equal to minus 11. So we're going to solve these simultaneously. So I'm going to multiply the second line by minus 1. So just write down the first line as it is. So minus b plus c is equal to minus 1. So minus b plus c is equal to minus 1. Now I'm multiplying the second line by minus 1. So 4b times minus 1 is minus 4b. C times minus 1 is minus c. And minus 11 by minus 1 is positive 11. My c's will cancel. So minus 1b minus 4b is minus 5b. And minus 1 plus 11 is 10. Then dividing both sides by minus 5, I get b is equal to minus 2. So we were asked to find the values of b and c. We now have the value of b. B is equal to minus 2. We now need to find c. So we write out one of the equations. It doesn't matter which one. I'm going with the top one. I'm going to swap the b for a set of brackets. And into the brackets, I'm putting minus 2. So minus 2 is positive 2. So I have 2 plus c is equal to minus 1. And then solving for c, getting c on its own, the 2 comes over, it becomes minus 2, and minus 1 minus 2 is minus 3. So c is equal to minus 3. So we were asked to find the values of b and c, and they are minus 2 and minus 3. So the actual function which was given was f of x equals x squared plus bx plus c. We now know that that function is f of x equals x squared minus 2x minus 3. So f of x equals x squared minus 2x minus 3. So this red curve, that's the actual function. F of x equals x squared minus 2x minus 3. So hence means using what you've worked out, write down the coordinates of P and Q. So these points P and Q. So now find P and Q. So here's our function. F of x equals x squared minus 2x minus 3. So these 2 points here, minus 1, 0 and P, these are the roots of the equation. These are where the curve crosses the x-axis. So P is a root. So to find P, we either factorize and solve or use the minus b formula. So if x squared minus 2x minus 3, we want to solve it. So factorizing, bring down the x squared, bring down the minus 3. This minus tells me that these signs will be different. So I've plus something x minus something x. The factors of 3 are 1 and 3 because it's a prime number, so only one factor pair. So we're going to go with 1 and 3. Now we have to be careful which way we arrange them. So we want to come up with minus 2. So 1 minus 3 is minus 2, so that works. We factorize the first 2. We get x times x plus 1. We factorize the last 2 terms. We get minus 3 times x plus 1. So x plus 1 times x minus 3 are our factors. We let it equal to 0 and solve. So if x plus 1 is equal to 0, x is equal to minus 1. And if x minus 3 is equal to 0, x is equal to 3. So these are the roots of our equation. So minus 1, 0 and 3, 0 are the roots. These are the 2 points where the curve crosses the x-axis. Or we could have used minus b formula. So we're going to draw in our invisible 1, label A, B, C, write out the formula, swap all the letters for brackets, and then start inputting into the brackets. So in place of A, we're going to put 1. In place of the B's, we're going to put minus 2. Make sure you use brackets here because you're squaring and it will go wrong if you don't use brackets. And in place of the c, we'll put minus 3. So then we simplify. So minus minus 2 is positive 2. And then minus 2 squared is 4. And minus 4 times 1 times minus 3 is 12. And 4 plus 12 is 16, all over 2. So we get 2 plus 4 over 2, or 2 minus 4 over 2. So we get 3 or minus 1, like we did over here. So we get the same roots. So we know now that P is 3, 0 because the other point was minus 1, 0. So P must be 3, 0. Now we want to find Q. So Q is on the y-axis, so its x value must be 0. So Q is on the y-axis, so its x value must be 0. So we're going to replace each of those x's from a function with brackets and put 0 into the brackets. So y is equal to minus 3. So that point must be 0, comma, minus 3. That point Q must be 0, comma, minus 3. Example 3. Functions f and g are defined as follows. F of x equals x squared plus 1 and g of x equals ax plus b, where a and b are constants. If f of 0 equals g of 0 and g of 2 equals 15, find the values of a and b. So f of x equals x squared plus 1. So f of 0 is going to be 0 squared plus 1, which is 1. G of x is ax plus b. So g of 0 will be a times 0 plus b, which is just b. So they tell us in the question f of 0 is equal to g of 0. So if f of 0 is equal to g of 0, and f of 0 equals 1, and g of 0 equals b, then 1 equals b, and b is equal to 1. So we now know what b is. So we found the value of b. So now we need to find the value of a. So we know g of x is equal to ax plus b, and g of 2 is equal to 15. So we're going to swap the x for brackets, and we're going to replace the b with 1, and into the brackets we'll put 2, and we let it equal to 15 because we're told g of 2 is equal to 15. And then a times 2 is 2a, because a number times a letter, we stick them together. So 2a plus 1 is equal to 15. So the 1 comes over the equal sign, becomes minus 1. So 2a is equal to 15 minus 1. So 2a is equal to 14. And dividing both sides by 2, we get a is equal to 7. So b is 1 and a is 7. So we were asked to find the values of a and b. So a is 7 and b is 1. Now we weren't asked to go any further, but if you had been asked to actually find the function, if g of x is equal to ax plus b, and a is 7 and b is 1, then the function is actually g of x equals 7x plus 1.